Hello everyone, this is Hugh from Thames Valley Automation, and I wanted to give a quick few-minute video on how we can design out the perfect Loxone panels and cabinets for our projects. Ultimately, so that we can end up with something as nice looking as this, really nice laid out, really well designed, no wasted space, but still have space for expansion if we need to, really easy to maintain, and most of all, quick and efficient for us to install. So to be able to get to a point like this, two prerequisites we're going to need. The first of those is we are going to need a parts list for our project, or most specifically, for the hardware that will be going inside of this panel. And then if we would like to do a full design from the get-go so that we have a panel that's ready to build, the second requirement would be a cable schedule. So this would be all of the cable schedules that exist within the property that are coming back to our Loxone cabinet. The project that I'm going to be designing today is this one here. It is a fairly nice and simple 3-bedroom semi-detached house. Ground floor, first floor. This is the ground floor that you can see here. It's going to have Loxone tree spots pretty much throughout with 1 or 2 additional light fittings. It's going to have multi-room audio. It's going to have some LED tape. And there's also going to be a couple of extra little bits like temperature sensors for heating control. And there's going to be some Modbus communications in there as well for mechanical ventilation. But all in all, pretty straightforward project. The panels that we as a company like to use for our Loxone systems are Future Automation's LXN-D panels. That's a picture of one that you can see there. They make them in 3, 4, 5 and 6 DIN rail panels. That's not my picture, that's a picture from Future Automation. And you can see there that that's a 5 DIN rail panel. So the very first thing that we're going to need to work out is how many DIN rails we're going to need on our particular panel. So I have my parts list here. And what I've done with this is I've just removed all of the items that don't go inside the panel. So all I am left with is the items inside our Future Automation panel. Then what I like to do to work out how many DIN rails I'm going to need is I like to work on a breaker unit or MCB size basis. Because all Loxone panel hardware, they have a measurement system in breaker unit sizes or MCB sizes. And I can tell you right now that you can fit 31 MCBs on a single DIN rail inside a Future Automation LXN-D panel. So that gives us a very, very nice formula for working out how many we need. So large Loxone extensions are 9 breaker units. This would be things like a mini server or a relay extension. Small extensions like a tree extension or an air extension, that would be 2 breaker units. The power supply and backup would be 18 breaker units. And terminal blocks, it does depend on the terminal block that you're using, but they're usually around half a breaker unit. So let's start counting these up. So how many large extensions do I have? I have 1, 2, 3. So 3 times 9, 27 there. Small extensions, I've got 1, 2, 3, 4, 5, and 4 there, so that's 9. So 18 of them. Power supply and backup, I have 1 of those. And terminal blocks, for terminal blocks, that's where your cable schedule comes in, so how many cables you've pulled throughout the house as a whole. I can tell you in this particular house, I think from memory there were about 12 cable runs. So we'll start at 12 terminal blocks, which will of course be 6 breaker units. So we then need to work out the total of the breaker units. So we have 69 breaker units in total. Then 31 breaker units per DIN rail means that we're going to need to take our total number and divide it by 31. So we are going to need 2.2 DIN rails inside our panel for this hardware. Now, of course, you can't break a panel down into fractions, so we're going to have to round that up to the next DIN rail. So we're going to need 3 DIN rails. It's also a good idea in general to be over rather than under. So for instance, if that came back at 2.9, I would suggest going to a 4 DIN rail panel so that you've got enough expansion possibility in there for anything that you might need to do. So the next thing is planning this out. The software that I like to use to plan my panels out is Affinity Designer. This can be used for pretty much all of your marketing uses. It's an alternative to Adobe Illustrator, I believe. Really, really good, however, for markups of both floor plans and also panel designs. And what I've done here is I have created some models of all of the Loxone panel hardware and also the future automation panels. These have all been made to scale as well. So everything that I design here will all be to scale. So I'm going to have to start first by creating a new file. Make sure that you choose a page size that's big enough to fit how big the panel would be in real life on there, because they're all to scale. So I'm going to go for A0 and I'm going to create that. And here's our nice A0 page. 2 really, really good tips with Affinity Designer when it comes to designing out your panels. First, go to View and press Show Grid. This will give you a grid here on the page, makes lining items up so much simpler. My second big tip is just up here. You have a picture of a magnet and it says snapping. Press that. And what that will mean is all of the objects will snap to other objects. So for instance, your mini server will snap to the DIN rail on the panel, making it so much easier to draw all of this out. Okay, the next thing we should do is let's get our panel onto the page. So as I said, we're going to go for the LXN3. Here it is, drag it out. Nice thing with the snapping is you can see you can snap it straight to the center of the page, so it's nicely centered there. The light grey items on my assets are the trunking, and the darker grey items are the DIN rails. So here's a DIN rail, here's a DIN rail, here's a DIN rail. Then, putting all of our components on this panel. I would always start at the bottom and work my way up. And for me, one of the first things, or one of the most important things that will go into the bottom of the panel are power supplies, which in our case is the power supply and backup. So I'm going to drag that onto the page. And you see what I mean there? That red line showing up? That means that it is snapping to that DIN rail. Makes it really, really nice and easy for us to center it on there. Whether you put it on the left-hand side or the right-hand side is entirely up to you. I like to try, if I can, when anything has mains going into it, to try and keep it as far to one side as possible, whether that be the left side or the right side, up to you. I would also recommend, when you're designing out your panels, you leave a little tiny gap at the ends of each DIN rail. That can allow you to put a DIN rail stop on there to stop things sliding about. But there's our power supply and backup on there, ready to go. Next, if we move on to this middle DIN rail, that for me would be where most of our Loxone mini servers and extensions go. So far left on this DIN rail, I would say, is probably where the mini server wants to be. Again, with a little gap there, because that then means that the Ethernet port has really nice access straight out of the panel without having to go all the way around the rest of the panel. We also have a tree extension in that panel, so that makes sense to put that next to here. Again, you can snap it onto this DIN rail. Sometimes the sizings can be ever so slightly out in these models. It doesn't make a huge bit of difference. Next, we could have either our airbase or our Modbus extension or our one-wire extension. I would recommend always leaving a couple of extensions space between the airbase and the mini server to stop any interference. So I'm going to go for the Modbus next, which will be one of these up here. And there it is, there's our Modbus extension. Let's get that on the DIN rail, and again that snapping comes in nice and handy. Then I have one wire, so find my one wire extension, put that on there as well. That's for temperature probes for the hot water tank. Then I'd probably consider it's time for the airbase. Again, a recommendation that you leave a little bit of a gap between the airbase and the mini server. And finally, in terms of this panel, I would say our dimmer extension. My reasons for breaking it out like this is on this DIN rail, the things that will have mains in them will most likely be the relays on the mini server and the dimmer channels on the dimmer extension. By having these as the two furthest away things on the DIN rail means that they have the least distance to travel to get into this main vertical trunking here and out of the panel without having to be wrapped around any of the signal cables and potentially cause any interference. It's just a way that I like to lay out my panels. So I'm just going to quickly go back to our parts list and just tick off the things that we have added. So we've done the one wire extension, we've done the dimmer, we've done the airbase, we've done the Modbus, we've done the tree. So I'm just going to paint those out so that we know that we've done them. Still have an RGBW dimmer to do. Okay, back to the DIN rail. So I have the choice here. I could move my dimmer extension up to the far right and put my RGBW dimmer in here, or I could put my RGBW dimmer next to the dimmer extension. I'm going to be using appropriately rated cables from that are rated from mains from the RGBW dimmer, so it doesn't matter hugely. My preference would be though to have the dimmer over on this far hand side and then to have the RGBW dimmer next to the airbase. So I'm going to put that there, move the dimmer back into place. There we go. So that's now the RGBW dimmer done as well. Mini server, yep, did that. Did the power supply and backup. So all I'm left with is the audio server and stereo extensions. So this is the audio side of things. Now this is where I differ a little bit from many other people when they design panels. So many other people might have designed this as a 4 DIN rail panel to make sure that this entire top DIN rail is free for terminal blocks and nothing else, no hardware going up there. Perfectly valid way of doing it. However, I like to keep all of my audio equipment at the very, very top DIN rail with all of the speakers terminated straight into the top of them. The reason I like to do this is because if there is one thing in this panel that we're probably going to notice any interference on the most, it's going to be speakers. Because anything that gets induced onto those speaker cables, we're going to hear out of the speaker. So I want to make sure that those speaker cables have the lowest distance that they have to travel in this panel before termination. So I'm going to add my 4 stereo extensions. 3, 4. And my audio server to this top DIN rail. So then the speaker cables terminate right into the top here without having to go through the panel. And this might not always suit, if I had a huge number of cables coming to this panel, maybe if I had 30, 40 cables coming back, I would want this entire DIN rail to be freed up, and I'd want to add an extra DIN rail in for the audio equipment. As it is, I only have a dozen or so cables coming back. So now we're on to this free bit of terminal of DIN rail, and this is where we're going to put our terminal blocks. So the idea behind our terminal blocks is they give a separation point between the cables going to the outside world, going to the house, and the cables going around the Loxone panel. The reason for that might be maintainability, so that you can have only 2 cables going into the panel that can then be split out to 4, 5, 6 cables going to the outside world. Or it might be for safety, So as an example of that, if we have a Cat cable, like a Cat 6 cable coming back to the panel, we don't really want those Cat cores to be floating around inside this panel, wrapped around with the mains cables that we've got going to this dimmer extension. Instead, we want to terminate this here and have appropriately rated cables going through the panel. So I think if we start first on this DIN rail with our mains cables. So for mains, what I've got happening from this system, first and foremost, is I've got, I think, 3 circuits of mains lighting. There's 1 circuit for the dining table pendants, and there's 2 circuits for outside lighting. 1 circuit for some wall lights on the front, 1 circuit for some wall lights on the back. Best terminal block to use for the termination of that is the twin and earth terminal block, which is this one here. And again, add a little bit of a gap so that you can add an end stop. So that can be my dining room pendants, that can be outside lights front, outside lights rear. Other mains things that I'm going to have in this panel is probably heating controls. On this system, we have underfloor heating downstairs, we have radiators upstairs, and we have a hot water tank. So that means for our heating control, I've got 3 zone valves to control. So 1, 2, 3. And there we go. With these assets, and by the way, if you want these assets, please feel free to get in touch with me. You can number up these terminal blocks. This again, really important from a maintainability point of view. Means that you can have an associated cable schedule that somebody can just open the panel, look at that, and they know where everything's wired to. You'll notice with these twin and earth terminal blocks that the earth from the twin and earth actually earths itself to the DIN rail, so we don't have to carry the earth cable around the panel. So that's already 6 cores of cable that we're not worrying about in the panel. Also with these twin and earth terminal blocks, we can also common up the neutrals. So this again gives us a big advantage for the cables going through the panel, because on all of the heating zone valves, for instance, they're all going to be common together. So all the neutrals are going to be common. It's going to be fed from the same breaker. So I've got a nice little asset here for that fuse connector to join all of those neutrals together. Same is probably true for the outside lights. The outside lights probably are being fed off the same circuit, so they can share a neutral. So I can add another one for them as well. And that's my mains cables accounted for. Next, I have my Loxone tree cables, because this is tree spots throughout the whole project. I have 2 tree cable runs per floor, so I've got 4 tree cables in total for this project. The 2 terminal blocks that we can use for tree cables is this grey one and this blue one. They look exactly the same, apart from the colours. We've got 8 terminations on the top, 8 terminations on the bottom, and 2 ways on each termination point. The difference is that on the blue terminals, each one of these levels is separated. So for instance, this level here only goes to this level here. On the grey terminal blocks, every single level is interconnected. So this level goes to this level, goes to this one, which goes to this one, which goes to this one, all interconnected. The ones that you want to pick will depend on the total number of tree cable runs that you have. If you're at a limited number of tree cables, so in my case I've only got 4, go for the blue ones, because I'm just going to need 1 per cable. If, however, you've got a lot of tree cable runs, let's say we've got 20 runs, go for the grey ones, because then you just need to break them up into power and tree. So you might end up with half as many terminal blocks as you have cables. But as I said, in my case, I've only got a small number of cables, so I'm going to go for the blue ones. Make sure you give a gap between the mains terminals and your tree cable terminals. And then I'm going to add my 4 of these in here. And again, number them. And there's my tree cables. Then, what else do I have? I might have some digital inputs. In fact, I do. I have 2 door contacts on this project. Those door contacts are going to be wired in either alarm cable or cat cable. So they again want terminal blocks. Again, the best terminal blocks for those are these blue ones. And again, give a little bit of a space. This allows you to add a separation block, allows you to add some labeling so that you know that there's a separation there between what they're doing. Perfect, and that's my door contacts accounted for. I've also got Modbus for my ventilation system, and I've got 1 wire for my hot water tank temperature probes. Each of those is going to be 1 cable. That means each one of those is also going to want 1 of these terminal blocks. And again, give a little bit of a distance to account for the different types of technologies that each of these terminal blocks is being used for. Perfect. Then if I have another quick browse at the panel, that's my relays sorted for heating. That's my tree cable sorted. It's my Modbus sorted, my 1 wire, and also a couple of digital inputs. Perfect. So the only other thing that I would possibly need to account for is the RGBW dimmer. I personally, again, whenever I can, like to pull the cable into the panel and terminate directly at the top of the RGBW dimmer. It saves on a terminal block, and also that cable is most likely a 5-core flex. It's rated for mains. It's fine to go around the panel. It's a flexible cable, so it's also easy to maneuver around the panel. So I would have that terminate straight into there. So all in all, that means that all of my terminal blocks are now accounted for. That's a panel done. You'll notice the power supply and backup has individually fused outputs on it, so you can select the correct fuse for what each one of these outputs needs to do. And then you just go straight from here to the relevant location. So the first one here might be to feed the mini server and the extensions. Second output might want to come to the first of these tree terminal blocks and loop across for your switch power, so on and so forth. Third terminal block maybe back up to these blocks for the spots power, 4th terminal block to the music, etc, etc, etc. The only additional thing that I might want to consider inside this panel is if I would like to add MCBs or RCBOs internally within the panel. This is down to an electrician's professional judgment. I would generally keep the fuse board as a separate entity. It gives a very, very nice differentiation between services, and it also means that you are ensuring any kind of regulation you might have on warranty of your fuse board. I might, however, be tempted to add a few smaller breakers inside this panel, so sub breakers for things like the heating control, maybe one for the power supply and backup, so I can shut the Loxone system off easily without having to turn other circuits off as well. And I might want to also feed my lighting circuits from here as well. And again, with these assets, you can change the size of these MCBs to your heart's content, depending on what you need to do with them. And there we have a fully designed out Loxone panel for a 3-bedroom semi-detached house. I do understand that all of this is very, very skilled work. It's taken me, to be honest, years to learn the best layout of panels, and also to learn how to then build and wire these panels. So if this is something that you are relatively new to, and you would like a little bit of assistance in getting started, or you're looking at this and you think to yourself, you know, this is really cool, but this is a service that probably doesn't warrant my time in doing it, then please feel free to reach out to us. We can offer full-fledged panel design services for you so that you don't have the hassle and the worry of doing them. But I hope this has been useful. I hope it's been instructional. I hope you've enjoyed. It's just a quick teaser to give you a little idea of how we do our business. Thanks for watching, guys.